Sip Hub.
Hello, welcome to the final episode of our series on how to use the graph calculator in graphing functions, relations, and other functions. Other calculations that we may need, especially when you are a student or you are a teacher. So in this presentation, I'm going to show you some other calculation function of this software. So we start with calculating the the length of a path. So you are given a function. We want to calculate exactly how long is that path on a given interval. And these kinds of problems are actually solved using ideas on a calculus course, specifically on an integral calculus course. That is because the definition of an arc length is the integral of the square root of 1 plus f prime of x quantity squared from the interval a and b. So from a to b. F prime of x here is the derivative of the given function f of x. And we see that doing this one might be tedious and needs more time, and of course needs our knowledge on integration. So you need to know how to integrate 1 plus f prime of x. F prime of x, also you need to know how to differentiate functions. I have here an example. If you want to look at this, let me make it bigger. Here is an example of calculating the path from a given function on a specified interval. So we have a function, a very simple one. It's actually quadratic. So this is a parabola. X squared, f of x equal to x squared. And we want to know the length of a path from 1 to 3. So the interval that is specified here is from 1 to 3. So before we can do that manually, if we want to calculate that manually, we need to compute for the derivative of x squared by power rule. If you recall our rule in differentiation, the power rule, if you have x raised to n, that's the function, by the simple power rule, the derivative is n x n minus 1. So you simply put the index, the power as the coefficient, and then subtract 1 from that power, from that exponent. That's why it's 2x. Now we can proceed computing for the arc length. So that's the integral of 1 plus 2x quantity squared. That's why it became 4x squared. And if we calculate this one using our techniques of integration, it would be approximately, why can't I see it? Yeah, because if we use integrating techniques, we would arrive at 8.27 units. So meaning, let me graph that function first so we can imagine better. So the function is x squared. So this is the function. And we want to compute the path, the portion of the graph, not the entire graph, but from 1 to 3 only. That's what's given in the problem. So it's like at this portion of the graph, we want to compute the path until this portion of the graph. So how long is that path? That's the problem. And as I mentioned, that can be manually answered by using a knowledge in differential and integral calculus. But in graph, it can actually directly compute for that path. So we can simply compute that by clicking the function first. So make sure that you selected the function you want to compute from, and then use this button, this one. Let's click that one. It will first ask us the interval that we want to compute. So we want to start from, again, 1 until 3. And it will automatically give us the value. It's actually 8.27 rounded. It's approximately 8.27 units, which is the same from what we computed manually. So that is how we use this button. It's for arc length. Actually, in our graph, it highlighted, it changed the color of the path that we just computed. So the original color of the graph is blue, but the path that we computed is colored black, automatically colored different from the original. What else can we do with this software, with this program? We can actually compute the area under curve. Area under curve is a really classic application of integration. So again, before you can compute for the exact area under a curve. So the curve could be any curve. It could be curve like this. That's the curve. That's the function. And then what you want is to compute the area under the curve on a specified interval. So you want to compute from A to B. What is the area? That's the problem here. And by definition, again, the area is the integral of the function. So that's f of x. It doesn't involve integration now. I mean, it doesn't involve differentiation, unlike arc length. You need to integrate f of x from a to b. That's the interval. So if we want to find the area under x squared from 1 to 3, then we need to integrate x squared and then evaluate it from 1 to 3. This is actually a shortcut, but the integral of x squared is x cubed over 3. Power rule for integration. And since we are evaluating from 1 to 3, we can make use of the fundamental theory of calculus, the second one. So that we have 3 cubed over 3 minus 1 cubed over 3. Simplifying this, we would have 9. That's because 27, 3 cubed is 27 divided by 3 is 9, minus 1/3. And this would give us what? 26 over 3 squared units. Approximately, that is the same as 8.67. So in our graph calculator, we can do the same. We can compute for the area under this curve. We just have to click on this button just beside the arc length button. We can do the same here. So of course, we have already indicated that the interval is from 1 to 3, so it's automatic. So this is the area that it is computing under the curve, and then from 1 to 3. And we see here that the area is also 8.66667, or approximately 8.67 squared units. That's how we compute the area under a given curve at a specified interval. That's all. Our final presentation on how to use the graph software. I hope you learned something, and I hope you can apply this one in your study or in your career. Thank you for listening.